Hey everybody, Lars here. Time for the second review video for Unit 2. And this one's a good one because once we get done with this video, you are going to have enough tools in your toolbox to actually start tackling some real problems. And you're going to see in a couple of days, I'm going to drop the third video on you. Probably going to be working out of the cave tomorrow. Tonight's Friday. Here in the friendly confines of my office in the Hill Mathematical Center on Bush campus. I'm going to be in the cave tomorrow, and I'm probably going to take some time to do your third review video for this unit, but it's not a core video. It's not something you need to do your assignments or study for the quiz. That's this, actually. Once you get this video, you're going to have all your resources. Zell chapter, slides, your 2 review videos, and then you can start working on the assignments. I'll probably release the assignments Monday, day after the Super Bowl, which as far as I'm concerned is Hitler playing Stalin, because I am a Cowboy fan and I hate the Eagles and I have no love for the Patriots either. So what are you going to do? It's like when the Yankees played the Phillies. It's like, who cares? You just want a meteor to hit the stadium. That said, I'll drop those assignments on you Monday. Probably get you the video for what you're gonna find interesting. It's about a website called Project Euler. It's about numerical analysis problems, and right now, simple data, if-then, strings, lists, loops. You're gonna have enough tools in your tool belt to go and tackle some of those problems, and that's actually what we're gonna do. We're gonna tackle problem number 6 over at Project Euler. But I'm getting ahead of myself. First, let's run through the second half of the slides for Unit 2, which has to do with loops. So I am going to go through a bunch of stuff with you. I have already gotten a little bit ready for us, not a whole lot. And what I've done here is I've created a list. I called it My List, and I assigned it a list of just 5 items. And as far as looping or iteration is concerned, in Python, it's real easy. You just iterate over lists. If you're familiar with those other languages, C++, Java, where you have to set up your variable, then set up your condition, then set up either an increment or a decrement or blah, 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 and then you have all this complicated thing. You don't do it. In Python, it's real easy. For I, and I will be our variable that we use as we go through the loop. You'll see what I'm talking about as we do it. For I in my list, that's it. Because my list is there, I do a colon, which sets up a block, just like our if-then. So I get a block, and then what do I want to do? In this case, I'm just going to print it. Now, as you go through the loop, every item that gets picked up is going to be equal to I, because that's the iterating variable. So I'm just going to say print I. All right? So when I run this, you see it just prints the items. Okay? But if I wanted to do something else, I could stay within the block, which is indented 4, and I could say print I plus 2. And there we go. And now I get the number plus 2, number plus 2, number plus 2, and as you can see, it kind of repeats there. Okay? I could, if I wanted to, I wouldn't have to do that. I could just do this. And do it all in one line. Okay? Do things like that, okay? But I just want to show you that you're not limited to just one statement. You can do as many as you like I can. I'll do the square right there, foreshadowing a little something we're going to do later. And there you go. You get the number plus 2, and then you get the square underneath it, okay? So that's basically what iteration is about. If you have a collection of things or a group of things, and you want to do the same thing to every single one of them down the line, that's what you do. You use iteration. Now, it comes in handy later, you're going to see, when we want to search through a list and find something. You go through everything, look at it, see if it's equal to something. If it is, you found it. You're good to go. Okay? So that's the beginnings of a list. But a lot of people will say, what if I like things the old way because I could set up a loop that goes 10 times, or I can set up a loop that goes 20 times. Well, we can still do that, but the way we do it in Python is by using something called the range function. It's not really a function, but we'll talk about that later. So if I wanted to say list the numbers from 1 to 10, okay, I could do it this way. I could say for I in, and then I use range to create that range of numbers, okay? But it's a little weird. because we want to give the first thing is the first thing we want, okay? Then, because it's an interval in Python, the second or closing part is going to be the first thing we don't want. So if we want 1 to 10, we have to go to 11, because the end of the interval or the range in Python is exclusive, okay? Then we tell it what we want the increment to be. So we want the increment to be 1, so that will give us 1 to 10 with an increment of 1. So if I print I, and you know what? Let's zots this out so it does not bother us. Okay, and now if we do that, you can see I get 1 to 10. All right? Now, what if I just did 11? Now I get 0 to 10. And we start learning a little bit about the defaults. The default behavior of the range is that it starts at 0, okay? The default behavior of range is that the increment is 1. So if I want to go from 0 to 10, I do that right there, okay? But you'll notice, and I'll rerun it so you can see, 0 to 10, all right? But if I get rid of the 0, well, if I get rid of everything but the 11, I'm going to go to 10. All right, so if you want to go from, say, 0 to 9, and you know that's what you want, well, then you can do it with just putting a 10 in there. All right, it gives you 10 items, all right, but it's 0 through 9, not 10 like that, okay? Now, we could also, if I wanted to, I could start at 0, I could go to 100, and I could say, give me every 5th number, okay? And when we do that, you can see we get the multiples of 5. So we can definitely do that. Another thing that we could do if we wanted to, watch this, we can go backwards. So if I put a negative in my increment, I'll start at 100 and I'll count down. As you can see, start 95, 90, 95, blah, blah, blah. Okay? So if you wanted to do, say, a classic countdown, I want to start at 10 and I want to end at 0 or 1, then I would give it, now I'd give it to 0 because 0 is the first thing I don't want. And then I'd say negative 1. Okay? Actually, I don't even know if I need the 0. And then I'd run it, and then I'd get a countdown, 10 down to 1. Okay? So understanding the behavior of range and using range to do things is a good idea. It's a way to make lists. It's a way to make lists of numbers. And a lot of times if you know you want to go over something 20 times, like if I want to do something 20 times, I'm going to start at 0. And I'm going to go to 19. That's 20 times, 0 to 19, okay? So that's kind of the way you can do what we call a definite loop. I definitely know it's going to loop over 20 times and do something, all right? Now, we know how to use range, so we can iterate for as many times as we want, but we also now know how to create numbers, okay? So you and I together are going to write a little program that actually does something. First thing I'm going to do is, I'll say the list. Do I want to say the list? I'll call it numList. I'll get a variable called numList, and I will assign it. See that? Bracket, bracket. That is an empty list. So that's a list I can now use. Then I'm going to say, for I in range, let's start at 1 and go to 300. So I'll go 301. And let's say numList.append, so I'm going to run the append method on numList, and I'm going to add I, okay? So now I'm creating in numList a list of the first 300 numbers, all right? Let's confirm that by printing numList when we're done. Dun, 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 dun. I misspelled something. numList, yes, we want to do that. And as you can see, there we go. We have a list of the first 300 numbers. But now that we have that list, we can use it. So let's do something programmery. Let's say I want to discover how many squares of those numbers are greater than 50,000. I think that's what I usually do in this instance. So what do I want to do? I'm going to iterate through that list and look at every number. So I'm going to say for I in, and after the loop is over, I can reuse that variable and I can reuse everything. So I can say in num list. I'm not using range anymore. Now I have a list and I know what I'm looking for. I'm going to say if I, ready for this? We're going to do it right in the decision. If I squared is greater than 50,000, print I. And there we go. We get, once we hit 224, that becomes true. But how do we really know that? I'm going to, I use double quotes. I could have used single. I'm going to print I squared right next to it. So now when I run it, I get it, and I can see that it is greater than 50,000. The first one I get is 50,176, and it starts at 224. Okay, that's pretty cool, but you know what? I really don't know how many of them there are, because that's what I really wanted to know, right? How many of them there are? So the way I can do that is to create a thing called a counter, and the way you create a counter is I'm going to create a variable called 0 right up there on the top. And that way, when I do have a number whose square is greater than 50,000, I print it, and then I say C equals C plus 1, or I click the counter, and I add 1 to it, okay? Actually, a better idea is to do this. The first thing I do is click the counter, and then I can print it. Watch me work. Now I know there are 77 numbers from 1 to 300 whose squares are greater than 50,000. Now there's one more thing we can do. It's a good technique, so I'm going to show it to you. Let's grab a variable called A. All right, and we're going to call that the accumulator. So I'm going to say A is equal to A plus. Now what should I put there? Not a 1, because I'm not clicking a counter. I want to add all these things together. I want to accumulate them. That's why I used A, accumulate. All right, now I want to actually put the item. I want to put I there. All right, and then what I'll do, let me leave my counter at the end. And we'll do that. So now we get the number, it's square, what all of the numbers have added up to so far, and the counter. Let's see if we work, and we do. Look at that. So if you added all the numbers up, you'd get something's wrong with that. Oh no, okay, it's not adding the square, it's adding the number. So we can leave it like that, because I'm just going to say it's less than that, but that's the square, not the number. If we wanted to do the square, we could do that. And then we get a big old number, the kind of the one I was expecting. Okay, so that adds up all the squares for all of the numbers, and there were 77 of them. Okay, so not crazy useful, little, you know, random, but those are the kind of things we can start doing now. We can start searching through lists of numbers. We can start doing things with numbers. We can start examining what is this, what is that. Okay, because I've got if statements, and I've got for loops now. And I can do counters and count how many times things appear in lists. And I've got accumulators, so I can add numbers up as I wrap through lists. Counting things and accumulating things are two very important things that we do when we use loops. So remember that. Remember how to do that. And later, I'm going to show you, you know, kind of what we would call a Pythonic way to do those kinds of things. All right. Now, I'm printing everything out here. If you wanted to, you could create a blank list and just add all those numbers to the list and then have the list to do something else with or examine later. All right, there's nothing stopping you from doing that. All right? Okay, so keep an eye on that. Accumulator, counters, very important things to remember, but we must move on. Onward and upward. We are pretty much at halftime. How many have we done? 15 minutes? That's about right. I'll buy that. For halftime, that's not bad. I think I'm doing pretty good space-wise here. So I'm probably not jumping around and creating a lot of things. Oh, my coffee is gone. Oh, I'm heartbroken. Oh, it's 5 o'clock, and when did I get that? Like 2? Now I have no more coffee. All right, there's 3 little things that I want you to see. I'm going to say for I in range, and I'm just going to do 3. And I'm going to say print. I'll use one of those. Outer, and then I. Okay? So now when I see this thing run, it just prints outer 0, outer 1, outer 2. So it goes 3 times, 0 through 2, which is the right behavior. Only now I'm going to do something a little different. I'm going to say for J. I don't want to use I because I'm still in the loop, right? So I got to use something different. Usually in programming, we use I, J, and K, okay, when we do iteration. So I'm going to say for J in range 5, print outer space I inner J. And what do we get? All right. This shows a concept called nested loops. You can run a loop inside of a loop. And as you can see, 3 times we print outer, and then for 5 times we run. So there's the first one, there's the second one, there's the third one. Okay, and as you can see, 0 through 4 on the inner ones. If you think about it, this is how, back in the old days, it's pretty much still the way we do it. We used to call lists arrays. Actually, some languages still do, C and Java and things like that. In Python, we call them lists. But we used to call them arrays, and you would have what are called multi-dimensional arrays. So this would be a 2-dimensional array in Python, which is a little confusing and a little kooky. It's just a list of a list. But we use this kind of constructor, this kind of technique to navigate through grids. Because if you think about it, you can treat the outer one as your row and the inner one as your columns. So if I'm in row 1, 1, 2, 3, 4, 5, I can go through the columns that way. So this is the way you would navigate table data or grid or something that was in a 1 by 1, 2 by 2 setup. Okay? So I wanted you to see it. It's, got the interesting behavior that you have a loop running inside of a loop. And if we wanted to run a third one, we could run a third one. And that's when you get to 3D coordinates and you do physics things and blah, blah, blah. So you can actually do 4D so that you have 3 dimensions of space and time. And that's how a lot of programs will work as far as tracking objects and where they are in contexts and stuff like that. Okay? So know about inner loops, know about outer loops, okay? What'll happen is you'll come in here, you do the first print, and then just like a regular loop, you'll run 5 times and then you'll end. And then when you end, whoop, you go back up to the top and do it again. You can see 1, 2, 3 times for the outer loop, but the inner loop runs 5 times. All right? All right. So, I don't want to delete that because at the end we're going to do a grand finale. Grand finale should be good with all of this code. All right, 1, 2, 3. 2 things left. So far, we have been discussing definite loops. I know that loop we just did was going to run 3 times. I know the loop inside it was going to run 5 times. When I was playing around with range, I knew it was going to run 20 times. When I did my little number criteria thing up there, I knew it was going 300 times and that I was going to save those numbers. What if I have a situation where I want to iterate, but I don't really know how many times I'm going to have to loop? That sounds weird and confusing, but I'm going to show you exactly what I mean. What if I have a situation where character Y, and I want to go into a loop, and when I'm done doing what I want to do, I want to ask the user, hey, do you want to continue? And if they say yes, well, then I go through the loop again. But if they say no, I don't. How would I do that? How does that get done? It gets done with a different kind of loop than a for loop. A for loop says for this, do this, and blah, 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 and we do it. We're going to use a loop now called a while loop. And what's special about the while loop is that after you say the keyword while, which turns orange as you can see, I'm going to give it a condition. In this condition, I'm going to say, while the variable character is equivalent to the letter Y, which it is because we set it up there, then go ahead and do what you want to do with your loop. So I'm going to print char, and then I'm going to go get a new y, and I'm going to say y equals input. Now remember, I don't have to cast input because it gives me a string, and that's what char is, so I'm in good shape. Actually, y, what a doofus. That would have blown up in our face. I want char. Char equals input, and I'm going to say, do you want to continue? I'll give it the question mark. Will be grammatically correct. I'll do that with a colon, and I'll do that. Now, when I run this, it's going to print the character, okay, which in this case is y, and then it'll say, do you want to continue? And I'm going to say yes, and then it'll print it and say yes, and print it and it'll say yes. If I give it something else, like an N for no, it'll come up here and it'll say, while char equivalent to y. Is that true? Well, that's not going to be true, so now I'm going to jump out. Okay, watch. Do I want to continue? Yes. Do I want to continue? Yes. And I can give it yes down the line. When I give it the N, it stops. Okay? Now here's the key. I'm going to run it again. Yes, yes, N. That loop ran 7 times. That loop ran 3 times. You don't know how many times you're going to loop through it, because in this case, this is 2 different things. This is an indefinite loop, and it's also what we call an interactive loop, because I'm the one altering the variable. You're asking the user for something while you're in the loop. That input statement happens inside the loop, okay? Now, you might be thinking to yourself, hey, Lars, hold on a second. I can give it, you know, y, but then I could give it an h, or I could give it a g, and it still jumps out because it's not y. You're right. We could always do this. We could always say, as long as character is not equal to n, keep going. And that way, when we run it, right now it's y, so we jump in. So do you want to keep going? Yeah, yeah, yeah. G, K, whatever. Newsflash, I could give it a word. I could give it all kinds of garbage, right? But when I give it the n, it stops. Because why? Because I said not equal to n. So that's no longer true when I give it the n and we jump out. So you could do it either way. A lot of people would do error checking, or I'm not going to get you involved with this, but something called an assertion, to make sure that somebody gives it a y or an n when you ask that question. Okay? But that's the beginnings of while loops. All right? So that you can do indefinite loops and keep going while a certain condition is true. I'll give you a clue. Every video arcade game you've ever played is inside of a while loop. Because at the end, when it says, do you want to play again? And you say yes, it goes right to the top of a while loop. That's how it's done. Believe me, I know. I've done them before. It sounds simple and crazy, but that's what it is. Every video game you've ever played is inside of a huge while loop. It's either while there you have a credit, or you know it has been paid, or while you say yes, or while whatever. Okay? So as long as that condition is true that you set up, you're going to keep looping, keep looping, keep looping. All right? All right, I love it. One more thing for us to tackle. And it's kind of interesting. It's kind of fun, and you're going to see why in a little bit. Look at all that code. Yeah, we're going to talk about that in a second. Think about it. What's today? Groundhog Day? I don't even know if the groundhog saw a shadow. It's 5:15, and I don't know. Pawtucket Phil, or whatever his name is. Let me do this first. All right, I'm going to create a list. I use my list. I use num list. What crummy variables. I will call this sent list. You will know why in a minute. And I will say sent list 2, 4, 6, 8, 10, 12, 300, and then 5, and then it doesn't matter. And you'll see what I'm talking about in a minute. All right. We now have a list called sent list. And let's say I want to add up the numbers in those lists. So that's easy because we know how to do that now. I set up an accumulator for I in sent list. A equals A plus I. When I jump out, I print. The sum is A. Run that. Invalid syntax. I won't have it. For I, you think I could put an in front of that so I do things syntactically correct? Another error. What's going on? What's out of balance? Something's out of balance. I have 2 quotes there, so I was expecting something different. See what happens when you go fast? The sum is 449. I'm going to assume that's correct because I don't feel like adding it up. Okay? That's great. We know how to add up lists now, and you don't have to print the whole thing up while you're doing it. I can just add them up and then print up the value, which is 449. Here's my question to you. What if I only wanted to add up the variables until I saw 300 and then stop? Okay? Sometimes we get those things. Sometimes you want to get to a certain value or something you're looking for. And in computer science, we call that variable the sentinel. Not the variable, the value. We call the thing you're looking for in the list the sentinel. So there's a certain kind of loop called a sentinel loop where you go through the numbers until you find something. Okay? And then you want to do something after you find that number. So what we want to do is we want to add up all our numbers here until we get to the sentinel. So 2 plus 4 is 6. Again is 12. That is 20. That is 30. That's 42. 42. Jackie Robinson. Or the number Douglas Adams likes. We want to see 42 because we want to stop adding things when we get to 300. So how are we going to alter our list, and how are we going to do things to look for it? So I could do this, I guess. When I get through the sentinel list, I can say if I is equivalent to 300, then do something. But what would I do? Okay? There's probably a better way to do it, and this is the way I would usually handle a sentinel loop. Is I would say if I is not equal to the sentinel, well, then go ahead and add. All right? What we have to handle is else. Because if it's not equal to 300, if that's not true, that means it is 300. That means you found the sentinel. And you've got to do something. And what you need to do is stop. So in the case of being inside of a loop and not reaching the end of the list and wanting to get out, what do? It's a Python keyword. You do something called a break. Now, a lot of classic programmers will tell you, oh, never break. Never use break, never use goto. There's different ways to do it, and there are. I mean, what you could do here is you could set a flag once you find 300 and then go through the whole list and ignore it. But what if the list is millions of numbers long and I find the number I'm looking for in like spot 70? Do I want to go through 50 million numbers when I've already found what I need? Sometimes when you find what you need and you're a good programmer and you know what you're doing, break isn't so bad. All right? Don't tell anybody I told you that. All right? But I'm going to give you the reals. Knowing that break is available and being able to break out of loops is okay. It's not suggested because classically in structured programming, you should be able to craft a program and never have to break and blah, blah, blah. I get it. But if you want to break, you break. So now let's look at our logic. I'm going to set A equivalent to 0. Then I'm going to jump in my list. If it's not equal to 300, I'm just going to start adding to the accumulator. When I hit 300, I'm going to break and I'm going to jump out. So we're going to do 2, 4, all of that up to 300. When I jump out and print A, it should be 42. If the programming gods are with us, if the Python gods are here, it'll say the sum is 42 because that's exactly what happened. All right? So that is something we call a sentinel loop. It's when you're looping through your numbers and you're looking for a particular value. Okay? All right, good to go. Now, I'm getting rid of this. Boom, boom, boom. But I'm also going to the top. Oof, and I'm getting rid of that. Look at that. That's going to be a nice little one. All right, we're going to run it. That's a big boy. Oh, wait, I'm not done. Do I want to continue? Yes, 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 and no. And then the sum is 42. All right. So let's go up here and look at what we got. We did just iterating over a regular list, and then we printed things out. We printed I plus 2, then we squared it, and we printed that out. Then down here, we did range of 20, and we learned 0 through 19. We could do definite loops and do whatever we wanted. Then we actually took our programming tools and actually solved the problem. We looked at the numbers from 1 to 300. We squared them. And we saw how many of those squares were greater than 50,000. Turns out there were, what, 77 of them? Let's see. Yep. Turns out there were 77 of them. And we added them up, and we looked at the squares, and we did all that. So then come down here, and we did inner and outer loops. to learn about navigating through grids and doing things like that. You can have a loop run inside of a loop so you understand nested loops. All right. Then we looked at while loops and indefinite looping. So you can go through that interactive loop as many times as you want depending on what you're given. So you're always looking for a condition there with the while loop. All right. And when you get to the top, not any time in the code, but when you come back to the top, you will look at that condition and see if it's still true. If it is, you run through the loop again. If it's not, then you go to the bottom. All right. And then lastly, we did something fun. We did the sentinel loop where you go through your values and you look for a particular value. And then when you find it, you get out of Dodge. So we ran that. We only added up the first 6 numbers. In this case, we got 42. All right. So that, and again, I hope you weren't coding this along the way, because I'm going to take this code and I'm going to put it on Sakai for you to play around with and for you to have. Okay. As far as announcements are concerned, I'm going to keep it a little light because I know I'm going to do another video tomorrow, and after that, the video on Project Euler, I can do a bunch of announcements, but there isn't much to tell you. The only real news is that I think after the weekend, either Monday or Tuesday, I'm going to release the information on the midterm project so you can get started on that. It's not due till March 11th. You're going to have a cool 5 or 4 weeks to do it. I worked a little on it earlier today because I wanted to change things up. A lot of people do things that, well, you'll figure it out when I give it to you. A lot of people do things with Python, learn Python the hard way they don't have to do. I don't want people spending money, and I don't want people doing things other than idle. So I fixed up the instructions a little bit, so that should be good. Other than that, keep doing what you're doing. This weekend, the TAs, Qasim, Kit are going to be going about grading the assignments, looking at the quizzes, doing all that. So at the beginning of next week, I hope to be sending out grade emails. I send out emails after every unit. You will get a grade email before the beginning of the next unit. So if you're sitting in Unit 2, you'll get your Unit 1 grades before the end of Unit 2. All right, before Unit 3 begins. Because we want to stay caught up, and we want you to know where you stand. And should I do an extra credit program? Do I not have to do an extra credit program? Things along those lines. As far as what I could see when I took a quick glance, everybody's in pretty good shape. I'm reading through the introductions right now. So you'll get your next week, you'll get an email about your grades. And I'll show you I literally just copy and paste the line from my grade book and send it to you. And I will explain to you what means what and what your actual grade is, blah, blah, blah. I'll do all of that stuff next week, probably in an announcement in Sakai. And then if you have any questions, you can email me. All right? All right, good. Then you have all of your resources for Unit 2, Zell readings, slides, 1 video, 2 video. Probably going to give you the assignments on Monday, day after the Super Bowl. Like I said, enjoy the Super Bowl. If you are a Philly or a Patriot fan, I am neither. So I don't necessarily wish you ill, but I don't give a rat's rear end if you win a Super Bowl or not. Have a good weekend. I'll be dropping the Euler video sometime next week, so be on the lookout for it. You are now at the point, and it's only been, think about the code you're looking at right now on the screen, and think about what you did today. And remember that you only started doing this 2 weeks ago, okay? And slowly but surely, we're starting to do things that are meaningful, that are going to be useful for data science. Being able to examine things in a list and using criteria to winnow lists down and do things, all right? It should start to make sense a little bit after this unit. And then Unit 3 is really going to square things up, because then you're going to learn about functions, you're going to learn about file I/O, you're going to learn about modularity and creating libraries, and that's really going to bring everything together. All right? All right, then I'm going to let you get out of here. And I will talk to you in a couple of days. You know me. I'm going to do a bunch of announcements. All right? Enjoy the weekend. I'll talk to you later.